Hello everyone, this is Henry Kim from Korea, the APEC president at the moment. Thanks again to you all who joined online and especially for the on-site attendant, the delegate participant there in Beirut. And especially I have to say big thanks to all the members of Lebanese Society of Endocrinology for organizing and preparing this Asian Pacific Scientific Congress, even though we still have the COVID pandemic whole global area. They are so brave and they made it for the on-site Congress for the first time after the COVID-19 outbreak. So we have to congratulate for the LSE members. I'm preparing this lecture for recording to share my idea at the 21st APEC Congress. The title of my lecture today is Instrument and Mechanical Implication on Clinical Efficiency. Before moving on to my lecture material, I would like to show you some photos of my city, Busan. Busan is the second largest city in Korea, located at the most southern east corner of Korean Peninsula, the seaside city. This photo is taken at my residential area, some part of Busan. It looks quite good, and at the daytime you can see like this mood. And sometimes we have very thick sea fog, and the sea fog makes a fantastic view like this. If you visit Busan after this pandemic situation, you can enjoy the beach area by taking the boat cruise. If you come to Busan, you can enjoy the famous food in Busan. This is the raw fish. Sometimes the fish body comes together, and here you see the fins are still moving, but it's not alive. So don't worry, just taste the fish meat. It's good. It will be good experience. Okay, let me start the main contents. This figure, we are very familiar with this figure from the textbook. It is explaining the basic principle of root canal treatment, and as you know, the cleaning and shaping is the main part of root canal treatment. To make a proper lumen for cleaning and obturation at the final step of root canal treatment, we have to use the instrument, the files. There are many files brands made of different alloy with different shape and geometry. We can classify them according to their shape and geometry and heat treatment, etc. The first group is just different in their shape, and all of them are made of conventional nickel titanium alloys. The second group, the manufacturer began to use the variable taper in the shaft, and they have cross-sectional asymmetricity for the special movement and special functions. And the third group, the manufacturer started to use the heat-treated alloy for better mechanical property. Usually they have the better flexibility, and it's quite good. We can make the brake curving for this using this instrument. And the last fourth group, they have some special function and kinematic movement for during the fire movement. The third and fourth are I think the most popular brands in this contemporary root canal treatment. All of these nighttime instruments are much advantageous than the other hand instrument made of stainless steel alloy. Whatever file you can select as your preference, they all can do better than stainless steel instrument. As you have the different taste for food, you can select whatever you want. But I may recommend to use the sequenced instrument system. That means the sequence means from the kind of order from orifice flaring and glide path preparation. Of course, we can change from the first is glide path or second is orifice flaring, but I may recommend use it orifice flaring first and glide path is second. And after that, we can use body shaping to make the proper lumen. I'm going to share my idea with some research evidences why I recommend this procedure, why I recommend those instruments. Although the nighttime instruments, nickel titanium instruments are very nice and efficient for the shaping, the fracture during shaping is a main issue for all clinicians. Of course, for me, it's kind of frustrating situation once we have some fractures. We know that there are two main mechanisms of the fire fractures. One is cyclic fatigue fracture and the other is torsional fractures. To reduce the fire fracture inside the root canals, there are some guidelines suggested, making glide paths, use multipliers with variable taper, with packing motion and something like that. Those numbered sentence. From number 1 to 4, they are aimed to reduce the flexural fatigue and torsional stress on the fires. For the same purpose, the first recommended sequence is to make flared orifices. This is the way for straight line access. And we know that this is the main principle of the root canal preparation. We learned it from the textbook. So the access is the key to success. To make successful radical access, we always need to remove the dentin sharp area. It is kind of mandatory step to make straight line access. We can access to the middle root canal or apical root canal systems. The files used for this cervical area to make proper radical access, they need to have higher flexural fatigue resistance because we may change the file's direction to remove the dentin sharp area. For this purpose, the one flare from Micromega, it would be a good option for use. The former file for orifice flaring from the same company that was end of flare, it was very steep and not so flexible, so it is somewhat difficult to do brushing motion for the removal of dentin sharp area. When we evaluated the new one flare made of T-wire, the cyclic fatigue resistance was increased and the torsional strength was not decreased, although with the higher flexibility. Usually, when the instrument has higher flexibility and also higher cyclic fatigue resistance, sometimes the torsional resistance goes down, but this one flare still have the higher good torsional strength as well as the higher cyclic fatigue resistance. This is good properties for our clinical uses. So we can use it not only for the orifice flaring to remove the dentin sharp area, but also we can use it efficiently for the retreatment procedure to remove the gut culture. I know that from these evidences, Micromega launched a new file, the retreat file. The name is Remover. It is almost in the same shape with the one flare. Anyway, any instrument for orifice flaring can make good radical access and straight line access efficiently than all the hand files. I think the heat treated files such as orifice opener, ProTape Gold from Dentsply, ProTape Gold SX, they are good enough as much as the one flare from Micromega. After making the orifice flaring, the next sequence is to make glide paths efficiently for proceeding the next one. But so again, the second is glide path preparation here in this lecture and my speech, but you can do the glide path preparation first and second can be the orifice spreading, but I recommend to use the orifice spreading file first and glide path is second one. It was the first guideline to reduce file fracture in the previous slide. Create glide paths to reduce the fractures. But here you can see to use the hand file. In this move clip, you can see the glide path establishment by using size 20 stainless steel instrument. But you can see here the file tip now making the ledge at the apical curvature area. It is mainly due to the stiffness of the stainless steel instrument. It's not good. So why we don't use the nickel titanium rotary instrument for the glide path preparation? We have many kind of nickel titanium file systems for the glide path establishment. Path file, G file, scout race. Path file is composed of 3 files, size 13, 16, and 90. They are all 2% taper. And G files from Micromega, they have 3% taper, sizes 12 and 17. And FKG launched the scout race, the size is 10, 15, 20 with 2% taper. All of these are very good, and some published articles reported that all of the nickel titanium files are much more efficient than stainless steel instrument. The novice operators can make the good glide path as good as the experienced operators, and there will be less deviation and less transportation than the glide path made by the hand instrument. And we can make the glide path good glide path in a very shorter time compared to the stainless steel hand instrument. That is the advantage for the rotary nickel titanium glide path instrument. But these instruments, glide path instruments, they are all very thin and tiny, so they are very weak under the torsional condition. As you see here, they may unwound, untwisting, and they may be broken easily at the very sclerotic tiny root canal system. So we have to know how to increase the torsional strength. In these geometric studies using the final element models, we compared the standardized models to see which component is critical factor to decide the torsional stiffness or torsional strength between center core area, the center, or the coronal cross-sectional shape and cross-sectional area. Which one is the critical factor to decide the torsional strength of the instrument? In the result, although the second model, slender rectangle one, it has smaller center core area, but it has a higher torsional stiffness and strength than the first triangle one. It shows something, it says something. So we could conclude the center core area is not the main factor to decide the torsional resistance, but the shape or total area of the cross-sections, it is the main factor to decide the torsional strength or torsional resistance of the instrument. Then how about the pitch? In terms of pitch, the distance of the cutting edge, the shorter pitch was shown to have higher torsional stiffness and torsional resistance than the longer one. It means the shorter pitch is better. So let's see the path file. As the path file has the square cross section, although it is very thin and tiny with 2% taper, it can endure the torsional stresses when it works to make the glide path, even in the very sclerotic root canals. If the path file is not a square cross section, it will be broken very easily because it is very small and tiny. Then have a look here. How about the triangle cross section from the G file or 1G? Those have irregular and asymmetric cross section. This study resulted It also have good torsional resistance and torsional strength at any levels, the multi-level from 2 to 5, 6, as much as the pacifier, because the 3% made it possible. If this irregular triangular shape or the triangle-based instrument, if it has the 2% taper, it will be broken very easily. But thanks to the 3% taper, it can endure the torsional stresses. This is good idea for the manufacturers, Micromega. Anyway, recently the glide path file systems are simplified to the single file systems. Among them, for the development and manufacturing of the 1G, we have some studies during the manufacturing process development. We have used the final element studies and fracture test together by using the prototype. At first, we made the virtual file using the final element models. The size was between G1 and G2, between 12 and 17. So we made size 14 and taper was 3% as same. And we compared the mechanical property using the final element analysis. Briefly, the result, the new design of prototype, size 14 and 3%, it showed mid position between G1 and G2. It's quite natural. And we asked them, the manufacturer, to make the prototype for the size 14 and 3% taper. And we compared with G1 and G2 actually. In the result of fracture test, as expected from the final element study, the prototype size 14, they have mid position between G1 and G2. And also the torsional test reported the same thing. The prototype has mid position between G1 and G2. Stronger than G1, flexible than G2. So it is quite good between two positions. And next question is that, how about the pitch? And do we need to have the heat treatment for the glide path instrument? After decision the size and taper, I and Dr. Rashid Arabet, my friend, had another study with this. We actually asked the manufacturer to make the shorter pitch instrument and a regular one, and heat treatment or not. So those two variables was compared for this study. This study revealed that the shorter pitch is better to have the higher torsional stiffness. And the heat-treated instrument, they have the good cyclic fatigue resistance, but for the glide path file, the torsional resistance is much important than the cyclic fatigue resistance. So we suggested the company to make the 1G, the new glide path instrument at the time, is already maybe 5 to 6 years old, so without heat treatment. So you can now use the 1G file without heat treatment. This study revealed that the shorter pitch is better to have the higher torsional stiffness, and the heat-treated instruments are not good to keep the higher torsional strength, because for the glide path instrument, torsional resistance is much important than the cyclic fatigue resistance. So the 1G did not went through the heat treatment. This is the one sample study for the R&D of the nickel titanium instrument. I would like to introduce some studies how to use the glide path instrument efficiently. The question is, in this study, how many times do we need to reach the apical end with glide path instrument to get a good glide path, to make the good glide path? We have compared the repetitive insertion to the walking length with 1, 4, 7, and 10 times. And we found that 10 times of repetitive insertion to the walking length, they did not make any transportation or deviation at 1 millimeter level, but make enough enlargement at the apical canals. So it will help the next coming shaping instrument. Here we have another study with Professor Ibrahim Uptown. He visited my lab and evaluated how much torsional stress is generated during the canal shaping by using the shaping instrument. In this study, we used the HyperX EDM after the various extent of glide path preparations. We also made the variables with the repetitive insertion, the number of repetition to the working length, from no glide path 0 and 5, 10, 15 and 20 times of the repetitive insertion to the end of root canals. In the result, as we may expect, we could reduce the torsional stress generation by doing repetitive insertion of the glide path pile to the working length. Again, we can recommend to use the glide path pile as much as possible. That is the safest way to reduce the torsional fracture for the shaping instrument. After we made good glide paths using these dedicated files, we can go for main root canal shaping. But before moving the next, between orifice flaring and glide path preparation, which one has the bigger effect on the stress generation during the main root canal shapings? What is important? This is the most recent study. It is recently published online at the Australian Endodontic Journal. In this study, we tried to see the torque generation after coronal flaring and or glide path preparation. In the results show that both of the orifice flaring and glide path preparation reduced, of course, they reduced the torque generation during the canal shaping, but the orifice flaring has a significantly larger effect than the glide path preparation to reduce the stresses. So it is much important, we can say, to make proper radical access with coronal flaring is more important than glide path preparation to reduce potential torsional fracture of the shaping instrument. Once we have good flared orifice and glide paths, we can use actually any file systems with minimal risk of fracture according to the user's preparation. Whatever you want, you can use it after coronal flaring and glide path making. But I can show you some research evidences that you may have some help, some information to select the body shaping instrument. Dr. Vasfi Ishik from Turkey, she visited my lab and we evaluated the torsional resistance of the instrument to see any effect from the shaft length. Because we have the instrument in the length of 21, 25, and sometimes we have the longer file, 28 or 30, 31. Here we compared the different shaft lengths. Those were 21, 25, and 31 millimeters. The results showed here the longer shafted files may have higher torsional resistance. So in our clinic, we may try to use the longer instrument when the patient, of course, when the patient can open their mouth bigger without any difficulties. In that case, we can use longer instrument to reduce the torsional fractures. Here we have another interesting R&D study related also to the file shaft. The manufacturer made a spring structure by laser cutting on the shaft, as shown here in the figure. You already saw that short move clip. We evaluated the effect from the machining of the spring structure at the shaft on the mechanical property of the instrument, cyclic fatigue resistance or torsional resistance, something like that. In the result of final element study, this is the first one, the final element file models with the spring, they were shown to have higher torsional strength and better fatigue resistance. So we concluded the spring machining may increase the mechanical durability of the instrument while we use inside root canals. That is computer simulation studies, but in this study, this is actual fracture studies. In this study, when we applied the spring structure to the brand file, in this study we used prototype gold and prototype next. The spring machined groups, we made the spring to the prototype next and prototype gold. The spring machined groups had shown to have better fatigue resistance and better torsional resistance. As you see here, the resistance is increased. Considering the prognosis of endodontically treated teeth, the vertical root fracture is another big issue for clinicians as much as the file fractures. All of these canals have vertical root fracture, as you see in the figures, the photos. We are not sure what is the main reason for these root fractures between the functional load or the root canal treatment previously done by us. Have a look at this old paper, this very old one published on 1991. About the half cases of endodontical failure was revealed to have vertical root fracture. The half cases of failure cases have vertical root fractures. And these failures were found at 20 months later root canal treatment in average. Do you have some cases or to have any patient who have recurring symptom 20 months after your root canal treatment? Actually, I have. Those cases might be related with the vertical root fracture after root canal treatment. This paper is quite new one, recently published about the vertical root fractures. It also reports that 5 times bigger number of vertical root fracture was found in the patient who have the root canal treatment. And also in terms of teeth, the endodontically treated teeth have 6 times bigger number of vertical root fractures. So we have to think that the root canal treatment would be highly related with the vertical root fracture. Then we have to think about the root integrity, the relation from the endodontic treatment to the root integrity. So we have another study about this issue. We try to see the effect from shaping on root integrity by using final element study. We use final element models. We could calculate the stress generation during the file models rotating inside the root canal models. This is the movie clip that the file rotates inside the simulated root canal, and we can see how much the stress is generated and concentrated at the apical foramen area. And we can take out the number of stresses. Using this simulation method, we compare the ProTaper F3 and profile size 30, 06 taper, and light speed. And as you guess the results show that steeper ProTaper instruments show that higher stresses on the apical root dentin. The stresses, under the condition of this study, the apical stresses by ProTaper and profile also, they are almost similar with the dentin's tensile strength. It means that potential crack may happen by using those steeper instruments. So I would say some file systems or a certain size of the instrument may threaten the root integrity and possibly may produce an apical microcrack. So considering this root integrity, we may select the files in the third group with heat-treated alloy for the minimal risk of vertical root fractures. This study, this one used the HyperX EDM. This is manufactured from electro-discharge machining. So why they have the EDM, electro-discharge machining. We could find interesting surface texture here. As you see here above, there is no machining or milling grooves. This is spark erosion surface. Of course, the high-plex EDM showed higher cyclic fatigue resistance and torsional strength than the other instrument compared. Interesting things are here from the SAM. You can see the fracture fragment. There are so many micropores on the instrument surface. These kind of micropores may have some effect on the mechanical property. The same thing was shown in the R-phase K3XF. We have another study. The micropores in the K3XF, we described in the discussion section. They have a role such as crack stopper and may act as a stress absorbent when the fire has stresses or microcracks. So these micropores may increase the fracture resistance of the instrument when the fire is made of R-phase or EDM. Definitely we can say the heat treatment and surface texture made the fire to have much better mechanical property. In our contemporary endodontics, of course, from the old dentistry, the minimal invasive procedure are quite popular. We are all pursuing this kind of minimal invasive, not only for the access cavity, but also for the shaping instrument. We are thinking about this minimal invasion. We can select any file brands, including single file system, to shape the main canal in a minimal size. But we cannot make the perfect clean by using the file system only. We know that the limitation of the mechanical shaping. We have to focus much more on the cleaning procedure than the shaping procedure. For this, we can use sonic and ultrasonic irrigation system. We all know that not only the mechanical shaping, but also the biologic preparation or chemical preparation is important. For the selection and use of nickel titanium instrument, we need to consider the purpose of each shaping sequence and need to understand the mechanical property of them and consider the root dentin integrity for the good progress in the future. Then we can enjoy our daily practice. Whatever system, whatever materials are your preference, the result and progress would be good. This is my final message. Thank you for listening and hope all of you stay healthy until we can get together freely. If you visit Busan, you may contact me for any tour information. This is my email address here. Thank you very much for listening. Thank you.